Hello everyone, Mr. Fawcett here, and we are back with another AP Calculus lesson. Today we're going to continue our discussion of differential equations and look at something specifically called a slope field. So let's just jump into some of the vocab. A slope field is a pictorial or visual representation of all the possible solutions to a differential equation. Remember that a differential equation is the first derivative of a function, f prime or dy dx or y prime, etc. And I just want to clarify, differential equations can include higher level derivatives, right? They can include the second derivative, third derivative, etc. The ones that we're working with in this class, though, they're not going to include those. They're just going to include the first derivative. Again, make it a little bit easier for us. Thus, the solution to a differential equation is the original function, or f of x or y. And again, general solutions to differential equations, they could just be equations, not necessarily functions. Again, the ones we're working with, though, when we're finding a particular solution, we are going to be finding a function. Because we have that constant of integration, there actually ends up being an infinite number of solutions to different differential equations. So let's just look at this example right here and kind of show why that is. In fact, pause the video and see if you can show or explain why this differential equation right here has more than one solution. Can you find more than one solution? Well, remember, we want to separate our variables first. So I'm going to get my y's with my dy, my x's with my dx. In this case, there are no y's. So I'm just going to be left with dy is equal to the quantity x plus 3 times dx. I'm going to integrate both sides. This one's pretty straightforward, obviously. And I get y is equal to 1/2 x squared plus 3x plus c. Well, this is the general solution, but if I wanted to specifically show that there are multiple solutions, right, or multiple specific solutions, I could just change that constant of integration. So I could have y is equal to 1/2 x squared plus 3x. I could just have plus 0, right? That would be one solution. And another solution could be y is equal to 1/2 x squared plus 3x minus 4. That would be another solution. And of course, you could just keep changing that constant of integration to come up with another solution. We're going to keep this idea in mind, right? That there are an infinite number of solutions to differential equations when we actually start to sketch slope fields. Now, there's a few different things, specifically 4, that you're going to be expected to do with slope fields on the AP exam. So let's look at those 4 now. All right, so you can pause the video and write these all down. But the first thing would be to sketch a slope field from a differential equation. Second, given a slope field, draw a particular solution to the differential equation. Number 3, match a slope field to a differential equation. And number 4, match a slope field to a solution of a differential equation. And again, we haven't really talked about what slope fields are, so that these may not make a lot of sense to you now, but have these down because at the end of the lesson, you will have learned how to do all these things. And then you'll understand, what's required from you or what you should be prepared to see on the AP exam. Okay, let's first start with sketching slope fields. Let's move to the next page. So it says sketch a slope field for a given differential equation. Okay, so when we're sketching a slope field, it's really exactly what it says, right? It's a field of slopes. So if we have this differential equation, dy dx is equal to x minus 1. Well, essentially what this is telling us, right, this is a derivative. So this is telling us the dy dx value for certain x and y values. So let's think about it. If x is equal to 1, so at x equals 1, dy dx is equal to 0, right? Because 1 minus 1 is 0. So, and in this case, there's actually no y values, right? So it doesn't matter what y is. Any place that x is equal to 1, my slope, my dy dx is going to be 0. So for every point here, I'm going to draw a little horizontal line. And what that is saying is that any place that x is equal to 1, our slope is going to be equal to 0. So we're just sketching in what that slope would look like. Well, now we can do it for these other x values that are shown. And we're not doing it for fractions or decimals, we're just doing it for integer values. So at x equals 2, dy dx is equal to 1. So you're going to sketch little slopes or little segments that look like they have a slope of 1. And here's the thing, you don't have to be perfect, right? The segments that you draw are not going to have an exact slope of 1, right? You're going to be off by a little bit. What the AP readers are going to look for is that all of these slopes in red are the same, and that if you have a slope that's greater than 1 somewhere else in your graph, well, it's going to look steeper than those red segments. Let's take a look at x equals 0. So at x equals 0, dy dx is going to be equal to -1. So here, they would want to see that you have a segment with a negative slope. Again, they're not going to get out, any instruments to see if it's exactly a slope of -1, but they want to see that it's negative and that they look the same as the red ones, except, opposite slopes. Let's see. We have x is equal to -1. So at x equals -1, dy dx is equal to -2. So our slopes here should be, I could actually just use my line segment tool here. Slopes should be a little steeper than they were in green, right? Because the green was -1, these are -2. And then likewise, at x is equal to -2, dy dx is equal to -3. So our slopes would even be more steep here. Not completely vertical, right? But more steep than the other ones. So this is how to sketch a slope field. This one was actually fairly straightforward because you didn't have to worry about any of the y values, right? If you had y values to worry about, then you may have to do more arithmetic to check, right? You might have to, instead of being able to knock this whole column out, right, in red, by just testing x is equal to 2, you may have to test x is equal to 2 and y is equal to 1, or x is equal to 2, y is equal to 2. So sometimes it can be a little more complicated, but that's the idea. You're just substituting in the values that you see on the graph, and then drawing a little segment with what that slope is. Let's look at the one below. Okay, so like this one has a y value as well. So pause the video, sketch based on the points, and I will put the slope field up here for you to check off once you finish. All right, so there's what the slope field should look like, and I just gave you an example, right? I chose a point 1, 2, and found that dy dx was equal to -1, so I drew a slope of -1 at that point. That would be right here. You probably noticed some patterns here. On the diagonals, going from left to right, the slopes were all the same, right? So if I look at all of these, they were the same slope, all of these the same slope, same slope, same slope, same slope, etc. So if you picked up on that pattern, you may have been able to save yourself a lot of time, because you definitely don't want to have to make, let's see, 5, 10, 15, 20, 25, 30. If you did each of these individually, there would be 30 slopes to evaluate, 30 dy dx's to evaluate, and you would not want to take all that time in the AP exam. So use some pattern recognition. When you can identify a pattern, go ahead and draw your slopes accordingly. They are not going to look to see that you show your work for every substitution, right? So this example right here, you do not need to do that work for every single point. That would be way too tedious, and you'd be taking longer than they intended for you to take. Okay, hopefully you get the idea about drawing a slope field from a differential equation. Let's now look at, if I have a slope field, can I sketch a particular solution? So it says to the right is pictured the slope field that you developed for one of the differential equations on the previous page. Now we want to sketch a solution curve through the point 1, -1. So we know our curve, our solution curve, has to go through that point, 1, -1. And now we're just going to follow the way that the slope field looks, right? So if I travel to the left of this point, well, it looks like I'm going to be going up like this. If I travel to the right, it looks like I'm going to be going up like this. So our solution curve here is an upwards opening parabola. And that makes sense, right? Because this, if the derivative is a linear equation or a linear function, well, if I take the antiderivative of a linear function, that is going to be a quadratic. So our original function here would be a quadratic, which is why we see a parabola. Now, this goes back to the idea that there's an infinite number of solutions for differential equations, right, based on what that c value is. So if I had chosen any other point, right, let's say I needed my solution to go through the point 0, 1, well, then I may get a solution that looks like this. So the slope field shows you what the slopes would look like at any of the different points, right? Because it has to cover all of the particular solutions. It has to cover, the general solution. But if you're sketching a curve of a particular solution, well, you're not going to be touching every point on the slope field. Because again, all of those different points, some of those work for different particular solutions, right? If I choose the point down here, well, then my solution curve may look like this. So again, start with the initial point that you're given, and then just follow the direction of the slope field. You don't want to go against the slopes, right? Again, the AP reader, they're not going to be picky about how precise you are. But if you started here, 1, -1, and you went downwards, or a downwards facing parabola, they would know that you have no idea what a slope field is actually telling you, right? Because the slopes, all along this line, well, those are negative slopes. But if you look at the curve you drew and you take the slope right there, that's positive. So it's going against what the slope field is telling you your function should look like. All right. I think you have one to try actually down below. Oh, just kidding. We're going to get some practice in class matching different slope fields to different particular solutions. So you'll see, and I don't do this work now because I will make a little game in class. But here you have a bunch of slope fields. Down here you have a bunch of differential equations, and you're going to be matching the slope fields to these differential equations. Then we have another activity where we again have a bunch of different slope fields, and we have solutions to differential equations. So you'll be trying to figure out, okay, if this is my solution to a differential equation, which slope field does it match with? So we'll do those in class. The last thing we're going to finish off with in this video are these two problems on the very last page. The first one says, shown below is a slope field for which of the following differential equations? Explain your reasoning for each of the choices below. So again, think about, and the way to do this is not necessarily to work out every single one of these equations and sketch and see which one matches. It's to quickly identify, okay, which one of these could not work and why, and then kind of narrow down your choices. So pause the video, think about which one works for that slope field, and then we'll discuss. Okay, so some things that I look for right away in a slope field are horizontal slopes. So what this slope field is telling me is that anywhere that y is equal to 0, our slopes should be 0. So, okay, are there any equations where that doesn't work? Well, the first one, that makes sense. Anytime y is equal to 0, our dy dx is going to be 0. Let's see, for the second one, yeah, that works as well. For the third one, also works. For the fourth one, does not work, right? Because there are times when y is equal to 0, but d would still be a non-zero number. Let's say, for instance, when x is equal to 1, then dy dx for letter d is equal to 1, not 0, even though y could be 0. So that one's eliminated. And then for E actually doesn't work either. And you can tell that because there are times on this, if I just look at the x-axis, right, which is where all of my slopes should be 0. Well, if x is 3 and y is 0, choice E is going to be 64, right? It'd have 3 plus 1 inside and cube it, and that would be 64. So I should have a very, very positive slope. But that's not what I see here. The slope field is telling me that, when I have the point 3, 0, the slope should be 0. So that lets me know that E is also incorrect. There's another point, or other places on this graph where the slopes are all 0, and that is when x is equal to -1. So when x is equal to -1, all of our slopes should be 0, regardless of what y is. Well, that's going to eliminate A, right? Because at A, let's say x was equal to -1, y was equal to 4. Well, then we should have a slope of -4. But the slope field doesn't. It has a slope of 0. So we can eliminate A. For part B, let's see, when x is equal to -1, and this may be a little tougher to see, but if I factor this, like let's say I factor out a y, so this is equal to y and then the quantity x minus 1. When x is equal to -1, inside of this parentheses, set of parentheses, I get -2. So when x is equal to -1, I'm going to get -2 times y, which doesn't always have to be 0, right? If y is equal to some other number than 0, then that entire quantity is going to be a non-zero number. So B actually doesn't work either. C, let's see, let's factor this. I get y and then in parentheses x plus 1. Well, in this case, when x is equal to -1, everything inside that parentheses, a set of parentheses, is going to be equal to 0. And then it doesn't matter what y is, dy dx is going to be 0. So C is the only one that works for those two spots that we checked on the slope field. So I don't even have to check the other spots because A, B, D, and E we could already eliminate. And if they don't work for certain parts of the slope field, they're not going to be the correct differential equation. Other things that you could check, right? Let's say that we still couldn't narrow it down to just one based on where the slopes of 0 were. You could then check for where the slopes are supposed to be positive, right? So you could look at, like, let's say this quadrant right here. Well, in the first quadrant, the slope field is always positive. So if I substitute in positive numbers for x and y, I would always need to get a dy dx that's positive. And you could see that works for this, right? If I substitute in positive numbers there, there's no way I'm going to get a negative slope. So again, just choose different parts of the slope field to help narrow down and eliminate different choices until you until you have one differential equation that's left. Okay, last thing for this video. I'm going to look at this problem right here. Make this as small as possible. Okay. It says consider the differential equation dy dx is equal to x divided by y. On the axis below, sketch a slope field for the equation. Okay, we could do that. Part B says sketch a solution curve that passes through the point 0, -1 on your slope field. Okay, we've looked at an example for that. Part C says find the particular solution y equals f of x to the differential equation with the initial condition f of 0 is equal to -1. And that's what we've done in our last lesson, where we found particular solutions. Pause the video, see if you can do parts A, B, and C. We'll check it together, and then we will be good to go. Okay, so let's take a look at our slope field first. Now, the first thing I want you to notice is that I don't have any slopes drawn when y is equal to 0, or anywhere on the x-axis. And that's because dy dx is undefined anytime y is equal to 0. And when your slope is undefined, on your slope field, you just want to leave it blank. You don't want to draw anything. And there were some other patterns going on, but they may not have been as obvious as the ones we did for the first couple where we sketched the slope field. So you may have had to do more substitution, substitute in certain x and y coordinates to figure out what the slopes were. And that's fine, but hopefully you picked up on some patterns, at least some way through your process. Or somewhere through your process, rather. So that knocks out part A. Let's move on to part B, where it says sketch a solution curve that passes through the point 0, -1 on your slope field. So the first thing I'm going to do is label the point 0, -1. And then I'm just going to kind of sketch what it looks like as it moves away. And again, they're not looking for a perfect sketch. They're just looking to understand. They're looking to see if you understand what the slope field is telling you to do with your function. So actually, if we had been given the point 0, +1, our sketch would actually look quite a bit different, right? It would be opening upwards rather than opening downwards. And this is because based on what your initial condition is, you may have two different functions for the solution to your differential equation, which is what we're going to look at in part C, is finding that particular solution. So we know that our particular solution looks like something we have in blue. Now we're going to find the algebraic form of it for part C. So I have my equation dy dx is equal to x over y. If I cross multiply here, I get y dy is equal to x dx. Pretty straightforward one to integrate. I end up getting 1/2 y squared is equal to 1/2 x squared plus c. You can either start simplifying now or you can find c first, then simplify later. I'll just go ahead and find c first. So at our condition was f of 0 is equal to -1, so 0, -1. That gives me 1/2 times -1 squared is equal to 0 plus c. And this gives me 1/2 is equal to c. So my new equation becomes 1/2 y squared is equal to 1/2 x squared plus 1/2. Now I want to get y by itself. I'm going to multiply both sides by 2. So that's going to give me y squared is equal to x squared plus 1. And then I'm going to take the square root of both sides. And just remember that you get a positive and a negative root. So you get y is equal to plus or minus the square root of x squared plus 1. So we need to see which one of these actually works. Is it y equals the square root of x squared plus 1? Or is it y is equal to the negative square root of x squared plus 1? Well, when I substitute in 0 for x, I want to get -1 for y. So that means this right here is my solution. I can only take the negative root. And if you graph this function on your graphing calculator, you will see that it looks pretty similar to what we drew in blue. Again, our sketch may not be perfect, but it starts at the right spot and it has the general shape of what I boxed in pink. All right, that is going to wrap it up for this lesson. As I mentioned before, we'll do those 2 graph sorting activities in class, so you don't need to do those ahead of time. As always, enjoy the rest of your day, and we will look forward to seeing you next time.